Good afternoon, everyone. We'll start the session. I'm again Ruth, and I'm delighted to welcome you all for the day 6 of our 5G essential tutorials. Over the past days, we have explored key topics such as 5G new radio, user equipment, and G-Node B, which form the backbone of 5G connectivity. We truly appreciate your engagement and enthusiasm throughout these sessions. For today's session, we will be diving into an exciting area, principles, which deals with principles of edge computing, 5G, and edge computing synergy and its use cases. Edge computing plays a crucial role in enabling ultra low latency applications with real-time data processing and seamless network experience in 5G. Okay, to guide us through this today's session, I'm pleased to introduce Anurag Datta Chowdhury. Is at the forefront of multi-access edge computing, virtualization, and AI framework development and DevOps at Niral Networks. He has a strong passion for hypervisors, AI, LLM optimization, and automation, making him a key figure in bridging the gap between intelligent networking and scalable infrastructure. His expertise in seamless integration and AI model optimization is driving the next generation of cloud native and edge computing systems. We are honored to have him with us today. Anurag, over to you.
Thank you, Ruth. Thank you for the wonderful introduction. Hi, everyone. Thanks. First of all, I would like to tell all of you thanks a lot for joining the session, for your valuable time. So today I have around 15 to 16 slides around with me to show you and scratching the surfaces of edge computing. And we will be covering of how, when, and where to do edge computing, which is the right way to do and when to do and how to do that. So starting with that, we will also have a small demo, which I have kept it alive. I have a running instance of Niral OS Edge where I will show you a live demo, how the edge looks like and how it works like. And followed by that, we'll also have a QA session where we get to unlock new things, where I get to also learn things from you, as well as I'll share my thoughts on your questions. So moving ahead to the first slide. First of all, the question when we talk about edge computing is, what is edge computing? So it is very simple, processing the data to near edge rather than processing it on cloud is called as edge computing. It lies in the name edge, where you process the data on the edge and return the response to the customer right in time without having any internet backhaul or sending the data to cloud, which adds a overhead of delay in the whole process. So what are the benefits? The key benefits such as reduced latency, such as you will have faster response to real-time applications. Now, applications such as normal web pages or a normal streaming server like video services like YouTube might not require real-time responses, but application like autonomous vehicles, drones, and multiple other things which rely on the server backend to respond to the crucial decisions which are made on the backend by computing multiple data sent from the sensors of the devices or the IoT devices. Their latency plays a crucial role and requires just-in-time reply with delays next to like 6 milliseconds, where even a millisecond of delay can have a significant impact, like catastrophic failure or any kind of accidents. Apart from that, we also would love to have more bandwidth efficiency. Talking about 5G is all about bandwidth and latency. So bandwidth plays a crucial role when you are uploading huge amount of data from your LiDAR sensor, when you are trying to upload a huge amount of data from your sensors or your devices for inferencing, where you want to send a live 4K data from your camera sensor to the backend for video analytics. In that kind of sessions, when multiple devices in a single area are connected, bandwidth is the key which will get your job done. So if you are relying on cloud processing, at that point your internet backhaul connection becomes the one-stop bottleneck for your bandwidth, because you may not have 10 Gbps or 100 Gbps of throughput. Whereas if you are just processing the application on the edge, your whole private 5G network or your 5G network might have that much capability on local level, which would be sufficient to get the job done. Followed by that, we would also consider enhanced security, as in we are processing the data on the edge, so our data is not getting exposed to the world, and there are no chances that even if our application or binary level, if the application security is not that up to the mark, still we should be able to manage or operate the things, because everything is in control, as in nothing is getting exposed. There is no chances of getting any DDoS attack on your backend servers or any kind of data leak. And one more important thing that is a concern in nowadays world is storing the data. For an example, if your application is deployed, if your network is deployed in some place which is very secure, such as a minting factory, at that point you would definitely not want all your data and all the fingerprints or different kind of watermark or the secure data of the coins and the notes which are getting printed to store any kind of XYZ server, which tomorrow can easily be recovered and on purpose can be hacked and is available to anyone who is accessing the web. Apart, so it is very much safe to store all the data in the server locally and keep it consolidated, so that keep it confined and preventing the whole infrastructure from getting breached externally or from some other places. And then finally we come to the improved reliability. So in terms of improved reliability, there are multiple factors in which a network's reliability gets impacted, such as, for an example, your network is working fine, devices are working fine, but all of a sudden you lose your backhaul internet connection. At that point, all the processing which was happening on the cloud will temporarily go down until and unless your backhaul internet is up. Even with having such a efficient network and investment in the enterprise level or any kind of private deployment, your whole thing will be now dependent upon the internet connection and the internet connection provider. The moment you lose connectivity, you are totally locked out and you will not be able to do anything. So to get rid of those things, edge plays a crucial role, where you do not need to rely on any of the communication outside the network, and everything can happen inside the network. So moving on to the next slide, I will cover few use cases where edge is a proper solution and in which places we should consider one. So in the first image, this is a latest agri farming land which has a private 5G network deployed in it, and the edge solution is sitting just next to the 5G core in this deployment. And as you can see in the image, we have tried to show that there are multiple IoT sensors available in each of the places wherever applicable. And we do also have drones flying over the paddy fields and connected to the 5G Genode base. Also, we have multiple IoT sensors installed in the greenhouses, and apart from that, we have multiple autonomous vehicles who are doing farming for us. So this can be a very good place where we can install the edge. So in my previous slide, I have always been talking about that edge is doing security, edge is providing security, edge is giving more bandwidth efficiency, edge is doing instant processing. So here are the few use cases. Like I was saying that it does not. So apart from only processing on things on the edge, a edge server can also be used for your own local AI inferencing. Instead of sending the data to cloud, you can run huge LLMs directly on the edge, and it is capable of doing inferencing, processing, training, and in real time doing RAG or any kind of other such stuffs just in the server directly in the location. And you can have your own model which can be retrained on another instance in the edge itself, and it can improve over time. Apart from that, edge analytics is another application which can also be implemented in such kind of scenarios. Apart from that, we do also have airports. So smart airports can also have edge implemented, where again multiple devices, drones, monitoring, analytics, and multiple other things can be taken care just by collecting the data and processing it on the edge. And apart from that, we do also have smart manufacturing. So in case of smart manufacturing, where you have multiple robotic arms, where you have multiple assembly lines, where automated machines are there, where you need a throughput of milliseconds, and in some places even lower than milliseconds, where multiple robotic arms make automobiles and other stuffs. So those can also be directly connected on edge, as all the robotic arms and all might not process all the data on the device. It may require a high-end backend. So the backend can be installed on top of edge. It can run, and using our 5G core network, all the 5G enabled devices can connect to the edge server, and they can be functioning relentlessly and high speed low latency for autonomous, and they can outperform in many use cases compared to normal deployments. Apart from that, we do also have one more deployment scenario which is very much viable, like ports, where things need to be moved over large spaces, and space optimization is also an important thing. So drones can be scattering over the ports, understanding how the containers can be stacked up, and how more spaces and how more in a more optimized manner containers can be loaded and unloaded, so that easily containers can be shifted from one vessel to another vessel. Apart from that, real-time workflow optimization using data analytics can also be done, and monitoring and analytics, of course. So these are the places where I feel that edge can be implemented. Apart from that, the limitation, there is no limit to it. Your imagination is the limit. So you can even what we cannot imagine today can be a deployment of edge. So any place where processing is required inside the network, edge plays an important role over there. So now, as we know what is edge and when edge can be used or should be implemented, now we will walk through few features about how edge works and what are the key features that differentiates edge from any cloud provider network or any normal bare metal processing. So first of all, why do we need edge computing? So as I already said, instant processing and bandwidth optimization that reduces strain on central servers, and enhance security, keeps sensitive data close to the source. And then we have ultra low latency. In ultra low latency, milliseconds matter of real time application. So all the applications which require milliseconds of response, where previously in normal design before edge we would have required to do all the calculation on the device itself, where we would have deployed multiple devices with high-end chipset can now be deployed with lower-end chipset, and as a backend, edge can work and give almost equivalent kind of response time compared to on device processing. And then higher speed and reliability. So higher speed and reliability helps IoT and AR VR experience improve drastically. So, so reliability is something IoT thrives on, as it constantly needs to send data to the main server through some kind of MQTT or some kind of protocol which most IoT devices use. Whereas higher speed is very crucial in terms of AR VR experiences, because AR VR require a huge amount of data bandwidth, because once you are using a AR VR headset, you are constantly rendering two 4K screens side by side for your left eye and right eye to give you a complete look and feel and create a stereoscopic feel for your eyes, so that it looks like you are viewing something naturally with your eyes. So AR VR is one of the use cases which requires a huge amount of throughput for the applications to run seamlessly. And the moment you lose bandwidth, or if you don't have good amount of bandwidth, your AR VR classes start, there is a desynchronization between the left eye and the right eye, giving nauseatic feels to the user, which makes the total solution useless. So this is something very much important. So we'll go a little bit deep down into industrial automation and how, in what terms, when I say industrial automation edge changes the whole game. So first of all, in industrial automation, what was our thinking in this industrial automation 5 years back from now, and what it is today is has changed a lot. So the assembly lines now require robotic arms, and also require huge, huge number of sensors for the things to be done. As we have now entered a more advanced stage where our silicon chipsets have become smaller in nanometers. So in industrial automation, it requires predictive maintenance. So doing predictive maintenance becomes a very important factor in industrial automation. As because now, more than manpower, robotic power is very much implemented in the assembly lines, as I already have explained about the sensors and the robotic arms. So understanding what can be our understanding the predictive maintenance, such as predicting the potential failures when they occur, and by doing that, minimizing the downtime, like having something as a backup, and also providing proper downtime to the devices, and estimating that what could be the final productivity after maintenance, plays an important crucial role in edge, because all the data which was previously getting stored in some kind of server, which was only being looked into once some kind of failure used to happen, or when something used to break down, can be now relentlessly monitored, as everything is available on the site, and we do not have any kind of issues with running some kind of analytics or some kind of AI inferencing on the data which we have for predicting such things. So we can run more those solutions more often to get a better predictive maintenance alert. Okay, I'll just check the chat. So moving ahead, next on the smart factories. So apart from predictive maintenance, I think which is applicable not only in production lines, but also predictive maintenance is applicable where the devices are actually functioning on the site or in production. So at that place, predictive maintenance is useful. Apart from that, now talking about smart factories. So as I already had shown few slides earlier about automation in factories. So using edge computing, intelligent automation in factories, optimizing resource allocation, production processes, and overall efficiency. So let's focus on the point that production processes and overall efficiency. So compared to a cloud, what kind of overall efficiency do we get better when we do it on edge? So if you do it locally, your data stays with you first of all, and as because everything is on the edge, you get a quicker response. Your devices has less amount of waiting, and due to that your devices can now perform more faster and resulting in less percentage of errors, which indirectly does increases the throughput and the efficiency of the production unit, saving in raw materials as well as also uh, um, able to create things with a better craftsmanship from machines or robotic manufacturing point of view. So next, we have autonomous vehicles. So the last 2 3 slides which I have shown are actually covering all the smaller or the more singular elements of which can be implemented in a all or implemented in multiple numbers or in multiple formats in the deployments like airport, automation. So autonomous vehicles can be there in airports also, autonomous vehicles can be there in ports also, autonomous vehicles in farming also. So the use case has to be defined by you or the application developer, and edge is just the placeholder or the enabler, and along with the 5G network to onboard your application on 5G and make it ready for today's and tomorrow's market to be acceptable and used by multiple devices which are coming and will be coming in the future and will be in use for good amount of time. So let's talk about autonomous vehicles. In autonomous vehicle, V2X communication is a very important topic where vehicles actually exchange data with each other. And apart from that, not only exchanging data with each other, but also exchanging data with your nearest traffic light. And there are few countries who have already implemented this and is working flawlessly. So in India, as of now, the vehicles use Google Maps and rely on Google's data. But just think, what if all the traffic lights and the map and your car, which drives autonomously, tries to sync to each other and is able to find you the not only the fastest and the less traffic route, but also the route which has the most less number of traffic signals and the ones where you have the highest probability of getting the green signal. So in such kind of use cases, V2X communication plays a very important role where it allows the autonomous vehicle to independently communicate with the nearest devices such as traffic signals, pedestrians, and other cars. So by doing that, it also reduces the amount of error, which directly reduces the amount of accidents that occur on roads. So I please don't be offended, but one thing our studies has proved, that is humans are terrible drivers. So they say that humans do not communicate in each other and are bad in communication with each other while driving cars. That's why due to due to misunderstanding between two drivers, we actually increase the amount of accidents on the roads. So it is a I mean, I don't know how much it is going to be in real time, like how it is going to work, or it's not going to work that well, or what might be the side effects. But they say that if all the vehicles one day on the road are driven by computers and all of them talk to each other, we can achieve a synchronization where we can reduce the amount of accidents and bring it to almost 0%. So though these things are very much in their starting phase, where some companies have taken off in some countries and are trying to work on this, but to work on this kind of things, your application cannot rely on cloud computing. Cloud computing, though, seems to be a really new thing, and still people are working around studying about it. But trust me, it already has started to grow old now, and now is the new era of multi-edge compute, or just computing at your edge of the network. So if you have a MEC server deployed in your car, so your car need not send the sensor data from your car to any other places. Rather, it can do all the calculation inside the car and can take a decision independently, even if tomorrow the internet connectivity goes down, which should be very useful in places, rural places, mostly in countries like India, where network connectivity at rural areas might be terrible, or even if it is there, let's say you want to still have the same quality of service which is there in a metropolitan city, or even the issues that are there in metropolitan cities. When you have a crowded traffic, your mobile data starts to lag, as because multiple people are connected to that same nearest mobile tower, and your Google map starts to lag. So in such places, V2X communication can be really useful. Apart from that, real-time I think V2X communication also uses some kind of AI for its learning and improvement. Apart from that, real-time AI, such as companies, multiple companies in India have started to deliver ADAS in their car, also known as the advanced driver assistance system. And ADAS actually has multiple levels, from right from level 1 to level 3. I'm not sure if there has been any advancement further, but which helps the driver to do lane keeping, cruise on that particular lane, and to also do collision avoidance. So for this kind of things, there is a huge bandwidth of data that is getting collected from the sensors of your vehicle, right from the front, back, left, right, directly into the system which is deployed in the car. And based on the sensor data, in less than of a millisecond, your car has to answer and take a decision instead of you holding the steering, and has to save you from meeting any kind of accidents. So just think what kind of latency is required, where which is not at all possible for our cloud backed computing, which is only possible through edge. So here it was all about the autonomous vehicles. Then moving on next, which industry is also picking a good pace in terms of 5G and edge computing, and is really a game changer, is healthcare and remote surgeries. So first in the list, we have AI powered diagnostics. So AI powered diagnostics, is it going to like remove all the doctors from its jobs? No, but it makes the diagnosis of any kind of uh, things which are not visible to the naked eye of a human being, or to the devices which is available or are available in in the vicinity of the patients are not capable of decision making or simulating reports from the diagnostics that what is going to happen from 10 years from now. So AI powered diagnostics enables that, and just by looking into a CT scan or any kind of ultrasonography report, a AI powered diagnostics tool can predict what would be the growth of the cyst or how fast the cancer cells are going to multiply in a human body just by looking into the report of today. So how is that going to be delivered to the customer at cheaper cost when you need to process a huge amount of data, you need to refer to a huge amount of data set and do a huge amount of processing every time you do the inferencing on AI level, because you are now, your whole solution is prepared in such a stack which is on the cloud. You will be losing lot and lot of money on paying the cloud provider. So why not have the same AI model run locally on your edge server and rather do the inferencing, which completely cuts down the cost of recurring manner repeating the cloud provider and directly running the solution inside inside the hardware in the on the premises, and this would drastically reduce the price of each diagnostic tests performed, and thus impacting thousands and thousands of lives more compared to what it used to, and also makes the product much more scalable. So you can now understand how edge not only works for fancy stuffs like AR, VR, or any kind of and luxury or entertainment, and rather can actually be a game changer. So again, I'll repeat the use cases, how to use this resource at best completely depends upon the app developer. This edge and 5G is just an enabler. The whole game changer and the whole thing still lies on the application level. Apart from that, talking about AI powered diagnostics, I would also like to refer to robotic surgeries. So robotic surgeries involve robotic arms, as we already have seen in last 5 to 10 years. Robotic surgeries have already made its presence in surgery, doing very critical surgeries, and where people can are able to do surgeries from a remote place, at a remote place where this surgery, I mean this robotic surgery probes are available, and people can be operated in real time remotely. So for such kind of complex calculations, such type of complex actuations of these robotic arms and controlling these things, you would definitely require a powerful backend which needs to sit along. So just think in such a way, till now all of these robotic arms had to be backed with individual high powered servers sitting next to these robotic arms, but now with the presence of edge server, there can be one small edge data center in the hospital which can be doing all the calculations centrally sitting, and rather decreasing the cost of each of the devices, which would result in the lower cost of the operation or the person being treated. Apart from that, we have telemedicine. Telemedicine, as in remote health monitoring and virtual consultations, where people from urban places and rural places can remotely interact, consult a doctor without traveling. So in those places where people then cannot where the huge amount of data cannot be transferred, at that places, if the rural place has a small edge data center or a MEC running there. So rather than sending that huge amount of data from the patient's cell phone or any device, and which would also take time for that much data to upload, the processing can happen there and the report can be generated just in time, and someone sitting far away can actually do or do such kind of diagnostics, and further you can be analyzed, which now requires for that physically that person to travel, and which is a waste of time as well as a hassle for patients. Then we have IoT based ambulance. I think IoT based ambulance is also something that have started to pick pace as of now. We have seen in last 2 to 3 years that multiple IoT based ambulances where cameras are already fitted into the devices. Apart from that, we have multiple devices like ECG, defibrillators, and multiple other machineries which directly need some kind of manual intervention or manual operation, or requires a good amount of compute power, can now be deployed in a ambulance and can be used, so that the moment the patient onboards the ambulance, the emergency part of the treatment can directly start in the ambulance itself. And once the patient stabilizes, meanwhile traveling in the ambulance towards the hospital, that patient can then directly be shifted to the ward. So these are the things where we have seen things are moving really fast, and I always want such things to actually happen, which really changes how we live in today's life and how lives will be saved in the future. So this is all about healthcare and remote surgeries. Moving ahead with smart cities and retail, which I think has already good amount of development and good amount of advancement has happened in terms of smart cities and retail. But now with 5G, we have a different story to tell. So in terms of traffic optimization, if you remember 2 slides back, I was talking about V2X communication, right? So we in V2X communication, the car directly talks with the traffic signal. So now, what if the traffic signal can also talk to each other and can actually understand that, and can tell the car that to take which route, or to when to change the color, and generate a algorithm between all the traffic lights in the city to optimize the traffic or to divert the traffic on requirement to a particular route, so that some routes can be busy, some routes can be free. Based on that, again, these IoT ambulances can go through, and so everything is as you can see, everything is connected to each other. So these are only the bits and pieces. Currently we are scratching the surface of edge right now. So once all the things fall on its own places, everything should perform smoothly, and everything should start talking to each other without sharing the important information, and only sharing whatever is required. So real-time traffic data analysis enable dynamic route optimization, reducing congestion and improving travel time. So right now we only rely on Google Maps and its traffic data, which is generated again from the data of your device when you are using. So multiple devices together inform the Google server that how fast the cars are moving. Based on that, it indicates green, yellow, or orange or red on the movement density of the phones. But what if I tell you the traffic lights itself has some kind of camera built in and can calculate the traffic density? Based on then all of these traffic signals start talking to each other, which can drastically reduce the congestion that is happening on the roads. Apart from that, AI driven surveillance. So using that same camera which is used to calculate the traffic density can be used to do the AI driven surveillance. For an example, if any car is breaking the speed limits, of any car is taking any kind of illegal u-turns or any kind of activities which is not supposed to happen, can now not only be stored in the server for future manual intervention or manual decision making, but in real time can be inferenced through a locally deployed AI model on that site itself in the traffic signal. And based on that, a decision can be made whether the car was driving in a rash manner or not. And just by computing multiple traffic lights data, we can generate a challan based on that. So not single sensor can give data to multiple binaries which are running, and then these binaries can directly talk to multiple different optimized models and can do inferencing, and based on that call out a decision what to do in that situation, which would have taken good amount of time or even at sometimes remain unnoticed when manually done by people. So in that at those use cases it can be really a game changer. And then finally it comes to retail. So talking about retail, I think self checkout centers is something is really booming right now. Inside outside India, I think there are multiple chains like Amazon also has its own self checkout counters and places where customer can go buy the stuff directly, go to a billing counter. There will be a camera where you just need to show the items. Automatically, you will be charged from your credit card that is added to your Amazon account. So in that use cases also, Amazon is able to do that, or any other company will be able to do that if they own their own server. But you have to understand, when you go to a retail store, in such kind of retail store, you are charging the customer for only the goods. So instead of that, if you now need to put huge amount of sensors, cameras, RFID detectors on the gate for security and for the ease, or to enable this smart checkout feature, you would need to process all the data somewhere. So Amazon is able to do as it own its own data center, or any other company who owns can easily do that. But what about, what if tomorrow some company who does not have competency or is not in that business plans to do that? Because it is not necessary that any kind of tech player will be also a very good big player in kind of retail market or any kind of that. So let's say suppose DMart tomorrow plans to do that. So what is most viable to them? In that case, what they can do is all of their retail stores can have their own edge servers, and there can be multiple devices who connect over Wi-Fi and who connect over Wi-Fi and I mean 5G and Wi-Fi, and directly connect to the MEC server. And the MEC server can run all the computing programs which will do the computing for all the sensors and cameras locally in the store. Now just imagine if there are at least 200 of checkouts, automated checkouts, how much in recurring you would have paid to the cloud provider, rather what you will pay now. So it was a recurring payment now, whereas it's a one time setup, and after that you can just forget and things can perform well. And as because this edge also can be vertically scaled, so tomorrow if you have more customers, you want more parallelism in the process, you can add more servers to the stack and can do scaling on the Niral OS edge. So this is how using edge we are looking into the different aspects of I mean the different aspects of the things which we are doing right now, but in more like a monolithic manner. And now slowly we are moving towards the advanced manner. So few of them, like few ideas which I share some of them might be already implemented, and few of them also might sound some kind of sci-fi. But to be honest, everything, once it comes on its own, all in its own places, and everything falls in its own places, I think things are going to be really nice, and we are going to have a really great future out there, by looking into, by using in these things, and some of them also even unknowingly using them or getting services from them. So next, we have edge computing technologies, like AI, multi-edge computing. So cloud capabilities at the edge, that's what I already covered. And then we have AI at the edge. So AI at the edge is a hot topic right now, because you are running, because you have to train, you have to run the model, you have to do inferencing, you want to do RAG, don't want to expose the data which you are trying to train. So in that cases, if you have any edge server which has some similar kind of cards which is available from NVIDIA, can be set up, and a single edge server can be used by multiple people in an organization, or can be used by multiple employees in a company at the same time, and can give you the exact look and feel of a cloud provided AI service at zero recurring cost. Apart from that, we have IoT integration. So IoT integration, as all of the devices need, these IoT devices need to connect to internet. So they will either connect to Wi-Fi or Ethernet, and then finally send all their data through MQTT or some kind of queue service to the cloud. For that, your cloud cannot be a serverless solution, as they will constantly, though the data rate is slow, but they will still continue to send the data. So you cannot run things like Lambda. Rather, you have to rely on directly always keeping the service up on backend, and you will be charged per hour. You'll spending lots of money to, even if you are doing a small amount of data and transfer as well as calculation. And if you have, let's say, a huge number of IoT devices deployed in an airport, where the number may range somewhere from lowest from 500 to maybe 10,000, calculating all the IoT sensors. So just think of the bandwidth that you will be transferring to the cloud, and the recurring cost for maintaining that service would be there. In that place, you can simply do all the calculation on the edge, and your data is with you, no leaks, nothing. I think that also covers the edge security along with that. Then finally, we have smart devices. By smart devices, I would like to talk about the VR glasses, or the wearables, which can be used to perform critical operations, which can be used to perform critical examination of coal fields, or quality of some kind of material, examining mostly wearable devices where there are multiple sensors, probes, collecting data, and also requires good huge amount of processing. And when multiple users wear it, also you are increasing the bandwidth. And then we have smart grids. So by smart grids, we have adjusting electricity in real time. So for an example, if you have a, in your power station, if you have the edge server, what can be done is, in terms of load sharing, and in terms of transmission, and in which phase how much to give, and when to give, how to give, everything can be controlled, and being computed, and also can be monitored, and that monitored data can be stored for analytics and future learning and improvement. So that is another place where edge computing plays a role. Apart from that, we have real-time data collection, like I already spoke about it. IoT device continuously generate data that needs to be processed quickly and efficiently. And then we have edge analytics. Edge computing enables real-time analysis data from IoT device, allow from immediate decision making. And then finally, AI at the edge. That is, AI models can be deployed on edge devices to process data locally. That is local inferencing from your own model or any kind of model which is directly available, which can be run using your local things instead of using the transformers which are available on the cloud, and then reducing latency and also improving efficiency. Moving on next, I think we have almost reached the end of the slides. Followed by that, we will have some kind of query sessions, and then I will also love to show you a small demo of how a edge solution or a edge dashboard looks like, a point of view. And yeah, so security challenges and solutions. So zero trust security is something in today's world, it is asked by multiple enterprise uh, companies, enterprise solution. It is something that is very normal nowadays. So the edge can actually work on zero trust security, where it does not trust any peripherals, and using zero trust policy, it directly connects to the 5G code, and it only gives data to the one which requires the data, and also does continuous verification, ensure only the authorized people or the authorized devices get access to the data of edge, and no device or user is automatically trusted in this. And then we have end-to-end encryption. So end-to-end encryption in real time and end-to-end encryption in some kind of stored data is very much different. So end-to-end encryption, if you want to do in terms of some kind of stored data, that requires some kind of compute. But if you want to do end-to-end encryption in the data which is getting generated in real time, that does require a good amount of compute, where again your data itself is getting generated in real time. So if you again need to wait for that same data to be encrypted by sending the data to for some out to the cloud for computation, that actually adds a latency overhead on the data, and thus making it more slower. In that cases, what is most preferred is running the whole encryption in your edge server. And just imagine two 5G users talking to each other, and the call needs to be end-to-end encrypted, so there is no man in the middle attack or any kind of sniffing that is happening, and your whole encryption server is now running on some cloud. So even if your 5G network has good amount of efficiency, still you will not be able to achieve the security which you intend or is required by the enterprise. In that case, MEC comes into the game. MEC will sit just in the edge of the network and will do all the encryption for you in real time and send the data to and fro between the two 5G users, which actually makes the data transfer really fast and does make the users feel that everything is happening in real time. And then finally, AI based threat detection. So AI based threat detection, where proactive identification of potential threats. So by threat detection happens on either signature matching or pattern matching. So in threat detection, you would require to store all these definitions of these signatures somewhere, and those needs to be compared and needs to be inferenced with your model at a very high speed and at a continuous manner to achieve AI based threat detection. In AI based threat detection, you have to not only run the compute continuously, but it is a huge amount of data when we are talking about this threat detection and protection for multiple users in the network. So to achieve that, again, like if you do that on the cloud, the main issue which you are going to face is if if there is some kind of issues with the detection, at that point the performance of this threat detection goes down, and there might be some kind of intrusion, or in where a botnet or some kind of things are used to attack your network. At that point, your backhaul internet may get overwhelmed, and it may go down, or will not be able to actually serve you as per your requirement. But if the whole solution is directly on the edge, at that point, until and unless someone physically invades or the network, the threat detection model cannot be taken down, and it will be running without any issues on the edge server, and everything will work. Everything will work flawlessly. So these are the security challenges and solutions that edge actually solves. So I think we can have the Q&A. So we can take a few questions, and then we'll have the demo of the.
Hi, sir. I'm Divya here.
Yeah.
Am I audible
Yeah,
clearly?
yeah. You are audible now. Yeah.
Yes. Sir, I just want to understand how are we planning for the secure by design to be implemented in edge computing? Are there any progress at present in terms of real-time devices or edge computing devices in the industry? And my second question is that in terms of legacy devices that are still in use, how can we adapt both edge computing devices and also the legacy devices together in the same infrastructure and keep the system running?
Okay. Okay. So, Divya, like, first of all, when you talk about devices, do you mean the end device which are used by the customers?
Yes.
Okay. So edge is not only about implanting the edge or doing the calculation directly on the device, or it's more like doing it locally. I think where edge comes is wherever your phone, for an example, you have a phone which has a AI tool to remove someone from the background, where previously if that requires internet connectivity, so at that point your data is now at risk. When you do that, you are actually sending your image to the cloud where the actual process is happening, and then that data is again being sent back to your phone, and now you view the image where the person or the background is removed from the image, and then you have the final solution. So the idea of edge is not to put that kind of compute power directly on your device, which would drastically increase the cost of that phone and would make it very much difficult for end users to buy or use that service. Rather, what if your network or your office network or your college network or any kind of network, I'm to the Wi-Fi which you are connected to, has that tool loaded into the MEC or the edge server, directly deployed in the organization or the institution which you are in, and can do it locally. So even when next time you just have the Wi-Fi connection, you should be able to do that, or the 5G connection to your private 5G network is there, you will be able to do that, rather than sending the thing on the cloud and creating and sharing the data over the internet, which tomorrow, let's say some company XYZ doing this with their application, their data may get leaked, and the sensitive content or the data which you are exposing to get the job done is getting leaked to everyone on deep net or something like that. So the idea is to replace the cloud with a in-prem solution, that is edge. So in that case, okay, coming back to your question, I think I made it too long, sorry for that. So coming back to the final point, that is, the devices which used to be there will still remain there, and the devices which are now coming will also coexist. Only one thing will change, that instead of deploying the backend server of the application or the app on cloud or AWS or any other Azure, rather it can be now directly deployed just next to the 5G core, where these application will directly be available to all the devices who use Wi-Fi, who use 5G, who use N3 IWF to onboard the network, can use the application directly at a better experience level. So Divya, does that answer your query?
Yes, sir. It does answer my query. I just have a follow-up question.
Sure.
So, in terms of infrastructure, also there will be a little changes, right? How it has to be like the edge computing device and the legacy device connects to the same infrastructure. End of the day, for the whole life cycle to be complete, right? So, how do we actually accommodate, or is there any changes in that? And second question also, like, sorry to add more questions, but in terms of some of the devices which are deployed directly in the customer places where it's accessible by the public, like for example in the smart cities, it's mostly accessible by the public, right? Like the smart electricity meters or the traffic signal devices that is there. So how do we actually plan or strategize for the physical tampering to be avoided? So, any thoughts on that also, sir?
Yeah. So, like one term that you just used, like MEC devices and non-MEC devices. So again, like coming to that point, there is actually in this place when we talk about the end device, like for an example, any sensor, any phone or anything. So let's say for an example, you have a phone which is 6 to 7 years old and that does not have 5G. Let's take the whole 5G thing and MEC thing out of our mind, and let's say some other person has a phone which was just released 2 months back and it has 5G, and it has 5G capability and all. Now let's say both your 5G phone, as it does not have 5G, is connected to the MEC via Wi-Fi, and that same MEC is connected to the other phone via the private 5G network. So in both the cases, there is nothing, zero change on the user level, that is the UE level, user equipment level, whether it be a camera or be it a sensor or your standard mobile device which we use. The only change is the part where the application backend was previously, it was done on the cloud, it was deployed on the cloud. Rather now it will be deployed in a hardware which is under your control, and that, and in so instead of reaching to the services using internet, now you can directly reach the MEC server through the N6 interface directly from your data plane, and you can access all that services. So there will all the previous user and existing user, if they should not experience any kind of changes, rather than improved latency, improved lower latency and higher bandwidth transmission. Apart from that, and answering to your second question, that is in terms of power meter or any kind of IoT devices which are placed in public places and or used by public, how is there any mitigation strategies to stop tampering with them? Is now, see, the security in terms of security, for an example, some kind of third party device onboarding onto the private 5G network or the MEC network, through those things can be detected on the infrastructure level, that the edge or the 5G core will take care of. But any kind of tampering into the device hardware, or any kind of tampering into the binary that is installed or running on these devices, and then that needs to be taken care by either the hardware manufacturer or the one who is writing the firmware for the device, or creating the software or the dashboard, or the, I mean, basically the binary.
Got it, sir. Yes, I actually wanted to know if there is any latest trends that I can know on those. But I think yes, you're right. Sir, one more thing, like um the one that you told about deploying a hardware, right? So that hardware is behind the public facing devices, right?
Yeah.
In terms of deploying for
Yeah,
processing. Uh,
let's say let's consider a corporate office where let's say we have a private 5G network, and we do also have multiple Wi-Fi access points, and all the employees have received 5G enabled, 5G SIMs, and the ones who don't have 5G are connecting to the network using Wi-Fi. So the point from which your 5G goes to the 5G network goes to the internet, or when you connect to Wi-Fi from the point where your internet gateway takes you to internet, Google or any other services, just before that the MEC is actually placed as a and that actually acts as your local data center. So instead of, even if your internet goes down, your MEC should be able to process the data on behalf of the cloud solution, and should be able to revert back.
Got it, so it's clear now. Thank you so much. Sir, are there any known regulations that we will have to take care of for critical infrastructures related to the edge computing and its security?
Yeah,
Uh,
in terms of reliability, I can tell you. So, in terms of reliability, high availability is very much required, along with hardware level redundancy, where multiple physical sets of identical hardwares would come together and do passive, active passive, or quorum level of high availability, so that if tomorrow you are doing any kind of mission critical services like drone navigation system or flight navigation system, so in that case, if your primary server goes down, it can automatically do a failover to the other two servers or any other instance of the solution where you are running it. So that is required. And in terms of security, obviously we require firewall. Apart from that, the edge server can also offer its own firewall, so that once the packets go inside the server, how to route them to different virtual machines that can be controlled. So these are mostly the infrastructure level securities which needs to be taken care of when talking about edge. Apart from that, like encryption or doing some kind of SSL certificate or TLS on binary level, that is always a extra, most something always welcome. But on infrastructure level, on firewall and how we are routing the packets to each of these virtual machines from virtual NICs, and this is something that needs to be looked into.
Okay, sir, got it. Thank you, sir. Sir, is there any regulations that more like the products have to be get certified for before releasing to the customer, something like that for any critical infrastructure edge computing devices?
So your query is basically like, for an example, you are asking tomorrow, if you have your own MEC server, is there any, is there any kind of certification?
Regulatory certification that needs to be done, if there's any certification body that has to certify this
Uh,
is like secured and
I
ready.
think it is like it is creating the technology and not creating. It's not about creating the service.
Mm-hmm.
It's very much different from offering data center as a service to people and deploying the data center for the customer. I think it's two very much different from each other. So there is no regulation body for this, but definitely the place where it is being deployed based on requirement of HA redundancy or any kind of intrusion detection or some kind of protective measures from the firewall gateway. I think those needs to be just validated, Apart from that, I don't think there is any kind of any kind of certification that is separately required to validate all this.
Got it. Got it. Okay. Thank you so much, sir. I think the others can go. Sorry for taking too much time.
No, no, thank you. It was just a last minute idea so that I can give everyone a quick look and feel, because I think like seeing is believing. So just I did not want to end up this session by only looking into the slides and just being very theoretical. That is not something I all prefer. So I thought that I'll have a quick demo, and we'll have the dashboard. So this is one of the edge server or MEC offering that is there from my organization, which I am working, Niral Networks. And we have built this solution in a very robust manner, which works with also without 5G network. And so this is the one-stop dashboard. And this edge server, as I was talking about, so we will just refer. If you have seen the slides very carefully, there was one of the slides where we were talking about the ports being deployed. And talking about ports, we know that ports belong to the government, and ports are given out at lease and to be maintained. So there are multiple players who can be there at the ports. For an example, there can be the Adanis, there can be DP World, there can be Marks, or any other companies who are doing their offloading and onloading near the shore. And at that places, you would require a solution. You would need to cater or collect data from common servers or common sensors, and that needs to be computed in a centralized server and then given back. So this is the one-stop dashboard where it does connect multiple vendors and uh, multiple sites, as well as multiple tenants all together and all their resources, and will be able to give you a complete overview. So currently I am logged in from the super admin point of view so that I can show you all the features quickly. So if I go here quickly, you can see currently I have 3 tenants who are directly connected, and they have licensing directly connected to this orchestration layer. That from there, one of them is our company also. Then if you go to the site, you should be able to select all the tenants, and you should be able to see for all the edge servers and in which sites they are currently installed. And then followed by that, if you go to resource, you should be also able to see all the resource currently which is connected. So if you see the nodes, these are the physical servers which where actually our node operating system runs, on top of which this MEC compute performs. And these are the two. And if you just filter, so we should be able to see for our company, these are the 2 servers which connect together, and we have scaled them for higher compute. So in each of the servers, we have a 48 vCPU and 126 GB of RAM, and both of them are connected together to provide a compute and also complement each other in terms of high availability and failovers. And down below, these are all the virtual machines which directly connect to, or which are currently created on top of these nodes and are working. And also you are able to see that what instances are down, what instances are up. So first, let me show you on node level, then I will show you on virtual machine level how actually the binary runs. Instead of deploying the solution on the cloud, how you can directly deploy the solution inside the edge, and how it can work directly in your local edge server. So if you go to the node, let me filter by the organization. So these are the 2 instances which are running. If you just click on the details, the moment you do that, you should be able to see all the details, like how many hard disk it has connected and how much RAM has been consumed, and then what is the network traffic over time in each one of them, what is the memory usage details. And also you should be able to view over the time what kind of, how the node is performing. And you should be able to also do it for the other node also. and you will be able to see a complete overview of when your system was down, when it was up, and you should be able to keep a track. So now for an example, now let's go little bit. Now we are done with the node part, that is the physical hardware where node OS is running. Now we will go little bit inside that, where we actually do the resource distribution and allocation based on what solutions we want to run. So this server has 48 vCPU and 126 GB of RAM. So that does not mean that I will direct. So what would have happened if you don't use a edge? You would have directly installed some kind of Linux distribution or any kind of operating system directly, where all the resource would get allocated to a single operating system, and you cannot control which application should scale how much, and all of them will be running in a single host process. So in case of failure or in case of any issues, there the whole system will go down and the whole system will come to a halt. But in this MEC server, where we are running multiple virtual machines on top of the on the edge, on top of the node OS, here if each VM has its own resource allocated and cannot cross that amount of resource, and if any binary malfunctions or misbehaves or any kind of issues are there, only that virtual machine is impacted and the whole system remains as it is, thus increasing the stability and the reliability of the service on the edge. So if I click on the virtual machines now, you should be able to see all the virtual machines that are created. And if I remove this, I should be able to see across all of them from my organization, and I should be able to see all the virtual machines that are running. So let's quickly go to one of them. So let's see what is the statistics. So you should be able to see all the statistics on virtual machine level as well, just like how you were looking into on node level. So here also disk usage, like input output delay, then CPU usage, network traffic, and multiple other things are available. And again, you can see the reports for last 24 hours, 1 hour and all. And then apart from that, you should also be able to do the whole life cycle management of the virtual machine, and like start, stop, all the standard functions. And not only that, so currently I'm sitting giving this presentation from a remote location of my office. So what you can directly do is you can directly get inside in any of the VMs, and you can simply click on the console. Just a second, I think there is some issue. This is not running, maybe. Let me check. So if you just click, so you should be you should be connected to the instance in no time, and you should be able to use the UI of the VM. And if it is not a UI, still you should be able to see the screen, which is directly you should be able to see the screen where CLI is coming for virtual machines which does not have a UI. Also, now as we have covered the VM level, so VM is the place where you create the instance and then you install the binary or your service. That can be on Kubernetes, that can be direct bare metal code, it can be Docker, it can be anything that runs on your system. And if that operating system runs on edge, that thing can be deployed and can be distributed and scaled to all the users connected to the private 5G network, or even to people where even 5G is not there. So MEC can perform over there also. And you can create the virtual machine based on your requirement. You can choose where you want to provision, you can choose in which node, and then finally, let's say I want to create a name of the dummy. You can select the OS type, like you can select Linux, and then you can select which distribution to install, and then finally you can select how much storage you want and from which hard disk. So this server has 2 hard disks installed. Out of that, in which one you want to install the solution, and then how much space you would require. then finally selecting how much CPU, vCPUs you would like to allocate, and then how much memory you would like to allocate. Finally, which network interfaces you want to add. And as I was already telling, that it already has a internet connectivity, so I can run any service inside this virtual machine, and all the users who connect to this MEC server, or all the users UE equipment that is connected to my private 5G network, can directly connect to the services and can start using the service. Moving on, next we have reporting module also. So for an example, you want some consolidated reports, let's say for this particular server which is running. So you should be able to view details for huge amount of time, or you should be able to also download this consolidated reports. Like let's say I want to download the report for last from today to date, from let's say first to 10th. I should be able to just download, and it should download in. Okay, I think there is some issues. Again, I'm connected remotely, so I may have some issues. So I'm not sure about that. So yeah, I think this was the quick short demo of the product, and this is how it looks like, how Edge should look like, and how Edge usually looks like. I think now you not only know about Edge, but also have a mere and pretty decent understanding how to use Edge. So this was all about the workshop of today. I think I'll I'll transfer it over to Ruth. Thank you, Ruth.
Yeah, Mr. Anurag,
Yeah.
sorry.
Yeah. Yeah.
One question. Do you have any, comparative analysis in terms of cost compared to this edge and computing and cloud services? Not only the application, also the manpower cost, because if we are going with the edge, so we have to, hire dedicated engineers network engineers who can manage these servers.
Actually, the beauty of the product lies how it has been designed. It completely actually depends. So, for an example, today, if you plan to bring up your own let's say some kind of website or some kind of service which is not which will be used by the employees of some company. So, if you go to deploy that on Amazon, that might not be that much straightforward, because for different providers, like let's say you have Azure, then you have to use Azure load balancer. If you use Amazon, you have to use different load balancer, and then you need to get a static IP and all the other things that you have to do. But in this, actually, the product has been built in such a way that anybody who knows basic networking and knows how IPs ping to each other, you don't need anything. And even if it is required, if someone does it for once, just like someone would have put that application on the cloud, then it is a simple process, and it goes on and on forever, and it will not crash, or any kind of monitoring or any kind of constant, I mean, servicing is not required until and unless your binary or the application which you are running demands that. One good thing about this Edge is you don't need to pay in a recurring manner. You need not think about to what is going to be my payment in the next month, because slowly I see there is an increase in traffic, because you have already scaled your solution from day one. Let's say if you have already purchased a server, a one time single purchase, you know and how much each people it should be able to cater. I think the until and unless you don't run out of resource, you need not think about it, and your payment is not fluctuating, or you will not end up paying in some kind of recurring payment or some abrupt payment. So I do not have a heads-on comparison with me today, but these are the quick insights which I have had to share with you.
Okay, thank you for this session, Anurag. As we wrap up today's insightful session on principles of edge computing synergy and use cases, We extend our heartfelt thanks to our speaker, Anurag Datta, for sharing your expertise. A quick reminder for the participants, tomorrow's session will be on 5G security by Mr. Pranesh from Prayova Innovations Private Limited. Be sure to tune in for another engaging session on time. Also, if you have any questions or doubt, please submit those questions in the query forms so that we can address them when you come here for the on-site demo sessions. Thank you all. Thank you. Have a great evening. Thank you.